All right, so let's do this dispersion and probability test together. So question 1, a bag contains some marbles. 3 are red, 4 are blue, 5 are green, and 3 are purple. The question is asking, what is the probability of picking a purple marble? All right, so how many different purple marbles are there in that bag, right? So basically I'm asking, how many different ways can I have picked a purple marble? And there's 3 different purple marbles that I could have chosen. And how many different marbles are there in the bag, right? How many possible marbles could I have picked? There's 3 red ones, there's 4 blue ones, there's 5 green ones, and there's 3 purple ones. That comes out to a total of 15 marbles. So 3 marbles are purple out of a total of 15 marbles. That comes out to 0.2. So there's a 0.2 chance that I pick a purple marble. But all the answers that are shown here are in percentages. So how do I convert from decimal to percentage? We have to multiply by 100. That's going to come out to 20%. Okay, so the answer for question 1 is 20%. All right, so question 2, we are given 5 out of 6 scores, as well as the box and whisker plot that is seen below. So here we have 5 numbers. There's a 6th one that should be here, but it's not there. And we have this box and whisker plot, and the question is asking, what was the missing score? So it's one of these 4 answers, okay? So very important, okay? Don't just look at this and go, oh yeah, you know, min, max, Q1, Q2, Q3, and go, oh, well, Q2 is 4, and 4 is not here, and so the missing value is 4, so I'm going to circle B. Okay, don't do that, okay? Because Q1, Q2, and Q3 are not guaranteed to be one of my data points. It's not guaranteed to be somewhere in my list, okay? The only 2 numbers that are always guaranteed to be in your data, okay, are your minimum and your maximum, okay? That's these 2 numbers right here, your minimum and your maximum. So minimum is 1, maximum is 9. They are here and here, so we have them in my list. Maybe we can make a new organized list here where everything's in the right spots. So 1, 2, 3, 4, 5, 6, right? We should have 6 numbers. I know my minimum is 1 and my maximum is 9, okay? So next thing we want to do is we want to find where my Q2 is going to go, right? We have to find Q2 before we even find Q1 and Q3. So to find where my Q2 is going to go, or my median, I have to know how many numbers I have, right? And how many numbers are there in this list? There should be 6, okay? There should be 6 numbers. So don't say 5 just because we have 5 in the list that was given to us, okay? There should be 6 numbers. So n is equal to 6. That is an even number. So to find where that median goes, we have to do n divided by 2 and n over 2 plus 1. So 6 divided by 2 is the 3rd position. And n over 2 plus 1, that's just going to be 3 plus 1, is the 4th position. So these 2 numbers, my 3rd and 4th position, okay, these 2 positions sandwich my Q2. It's going to go right here between those 2 numbers, all right? Q2. And what is Q2? Q2 we said was 4, all right? So Q2 over here is equal to 4. All right, so because it's between these 2 numbers, that means that it's going to be the average of whatever's in this 3rd and 4th position, but it's not going to be a number in my data necessarily, okay? That's why we didn't just like circle B right away, all right? Because it's not guaranteed to be a number in my data. As you can see here, it's between 2 numbers, okay? Next thing we want to do is to find Q1 and Q3, my 1st and 3rd quartiles. So Q1 is just the median of my 1st half, and Q3 is the median of the 2nd half. So the amount of numbers in my 1st and 2nd halves should be the same, right? If you have something different, if you have 4 in your 1st half and 2 in your 2nd half, then you found the wrong position for Q2, all right? So we go back and redo that part. But here we have 3 on each half, so we say H, which stands for half, is equal to 3, which is odd, okay? So because it's odd, we don't have to do this n over 2 plus 1 thing, okay? We can skip that. We just do n over 2, or in this case, h over 2. which is 3 divided by 2, which is 1.5. The 1.5th position doesn't really make any sense, so we're going to round it up to the second position. All right, so the second position of each half is where my Q1 and Q3 are going to go. So Q1, so 1, 2, right here is Q1, and 1, 2, right here, the second position in my second half is Q3. Now, what is Q1 and Q3 equal to? Let's look at the box and whisker plot. Q1 is 2, Q3 is 7, okay? And you can see here Q1 and Q3 are pointing into a position in my list. They're not between two numbers. So Q1 and Q3, which are equal to 2 and 7, are actually numbers that should be in my list, okay? 2 and 7. Let's see if they're in my list. Let's scroll back up. 2 and 7, yeah, they're in my list. So they're not my missing values either. Okay, that leaves me with one number in my list, that is 3. And we have 2 potential spots where we can put that 3. But we know Q2 is 4, so 3 has to go right there, right? Because 3 is less than 4, and we're putting this in increasing order. So that leaves this empty spot for my missing value, that's x, okay? And like I said before, because Q2 is between my third and fourth position, it's between these two numbers, then the average of these two numbers should be equal to Q2. So how do I find the average of two numbers? I add them up, 3 plus x, and I divide by the amount of numbers I'm adding together, which in this case is 2. And that's going to be equal to, like I said before, my Q2, my median, which is 4. So I cross multiply, I get 3 plus x is equal to 2 times 4. Okay, so 3 plus x is equal to 8. X is equal to 8 minus 3, which is 5. So this x right here is equal to 5. That is going to be the answer for question 2. All right, so moving right along to question 3. So Maria, Zirak, Luca, Nikki, Nilay, Serene, and Alina are lining up to participate in Mr. Hum's fun and exciting lunch party. How many different ways can these 7 students order themselves in line? Okay, so let's think about this. How many different positions are there in this line? So there's 7 people, so there should be 7 spots, right? The first, second, third, fourth, fifth, sixth, and 7th spot. Let's start at the very front. My first position. How many choices do I have, right? How many different students do I have to choose from to put in that first spot? How many options do I have? Well, there's 7 students, so I have 7 people to choose from, okay? Now, that first spot has been filled. So I chose someone, I put them in that first spot. Now, how many options do I have left? Well, there's 6 remaining students, right? After I place 2 students, there's 5 choices left. Then there's 4, then 3, then 2, then 1, right? So 7 times 6 times 5 times 4 times 3 times 2 times 1. Try that in your calculator. You should get 5,040, okay? If you also recognize this as a arrangement question, you could put 7 factorial in your calculator. You'll also get 5,040. So the answer for question 3 is 5,040, okay? So we'll just scroll down here, and we'll shade this in. It was C, C, and C. All right, so question 4. A marble is randomly dropped over a 100-meter long line. So this line in this diagram, we know in total it should be 100 meters long. What is the probability that the marble lands in the section between D and E? So that's this section right here, okay? Between D and E. So remember that the formula for geometric probability is the favorable length, right? In this case, we're dealing with lengths, not area. So favorable length divided by the total length, okay? So the first thing I want to do now is just to figure out what this length, this favorable length is, right? The length that I want to land in, okay? So if I know that this section right here from A to D is 20 plus 30 plus 35 meters, that comes out to 85 meters. And I know in total this line is 100 meters, Then from D to E, this length is 100 minus 85, which is 15 meters, right? So my favorable length, that section between D and E, is 15 meters. And in total, we have a 100-meter long line, so 100 meters. If we take 15 divided by 100, that should give you 0.15. So there's a 0.15 chance that I land in between D and E. So you could box this answer in. If you wanted to give it as a percentage, that's also fine. You just multiply by 100, you get 15% chance of landing between D and E. Okay, so question 5. Mr. Hum's laptop password is made up of 4 characters. The first 3 characters are each one of the following letters, A, B, C, D, and E, and the letters can be repeated. The last character is a digit from 0 to 9. How many different possible passwords are there? So how many different characters do I have? How many spots do I have in my password, basically? And we know there's 4 characters. So there's 1, 2, 3, 4 spots to fill, okay? The first 3 characters are letters, so L, 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 and the fourth or last character is a digit from 0 to 9, okay? So my first letter, or my first character, how many options do I have to fill this spot? I know it's a letter. It's one of these 5 letters, so I have 5 options, okay? My second character, my second spot, how many options do I have? How many choices of things do I have to fill that second spot? So I know it's another letter, right? And because letters can be repeated, just because I used, let's say, like B for this first letter, okay, I could use it again in this second letter, okay? So we still have 5 options, okay? And same thing for my third character, the letters can be reused. So it's not like, once A is used, it can't be used again. I still have 5 options, okay? The letters can be repeated. And my last character is a digit from 0 to 9. How many digits are there from 0 to 9? Okay, don't be tempted, well, most people are tempted to say there's 9 options, right? 9 characters, 9 different digits. But if you actually write these out, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0, you'd see that there's 10 options. There's 10 different digits. So there's 10 digits here. There's 10 options. And we're just going to put in a bunch of multiplication signs. You get 1,250 possible passwords. Okay? Now, B. Using your answer from A, what is the probability of guessing the right password? Well, there's only one right answer out of 1,250 possible passwords. So you get 0.0008. Okay? You have a 0.008 chance of guessing it right, or a 0.08% chance of guessing it right. Now, question C, is the answer from B the experimental or theoretical probability? So remember, experimental means we've done the experiment, we've tried it out ourselves, and we're looking back at the data. Whereas theoretical probability is we're just doing this on paper. So the question you should ask yourself is, did someone go to my laptop and spam a bunch of passwords like 1,250 times before they got it right? No, they didn't try the experiment. They didn't go to my laptop and try in a bunch of passwords. So this is theoretical probability. Okay. All right. So question 6. The prestigious Hum Institute of Mathematics, or HIM, is hosting an event. Mr. Pagano will go skydiving, and if he can land in a marked and shaded area, the school will give him a crown that says HIM to let the world know that he is him. Mr. Pagano can choose to skydive over 2 different fields, which are shown on the following pages. Which field should Mr. Pagano choose if he wants to have a greater probability of landing in the shaded region? So he wants that crown, right? He wants to let the world know that he's him. So he wants to choose the field that gives him the better chance of getting that crown, okay? Or landing in that circle or shaded region. So in field 1, we do have a circle that's shaded, that's inside the big field, which is a rectangle, all right? So we want to land in that circle. Let's find out what the area of that circle is, yeah? So the area of the circle, remember, it's pi times the radius squared, pi r squared. And the radius is the distance from the side of a circle to the center of the circle, right? And so in this question, we aren't given the radius, but we're given the diameter, which is the distance from one side to the other side, okay? And we know that is 20 meters. But if we know the radius is just from the side to the middle, then it's just going to be half your diameter. So r is equal to 20 over 2, which is going to be 10 meters, all right? So we take 10, we plug it back into my formula, we get pi times 10 squared, which is pi times 100, which gives you 314 meters squared. Now, let's find the area of the field, the total field, which is a rectangle. The area for a rectangle is base times height. The base is 25 meters, and the height is 20 meters. So that's going to come out to a total of 500 meters squared. Now, for geometric probability, it's always going to be favorable over total. Last time, I think it was question 4, it was favorable length over total length. Now we're doing favorable area over total area. So what's my favorable area? That's the area that I'm interested in landing in, which is that shaded area. So we have 314 over 500, and that's going to give you 0.628 or 62.8% chance, okay? So keep that in mind. We're going to come back to that. So field number 2, we have a triangle inside of a trapezoid. Let me fix this real quick. The formatting's a little off. Okay, so we've got a triangle inside of a trapezoid. So let's find the area of my shaded region, which is this triangle here, right? So what's the formula for the area of a triangle? It is 1/2, or half of base times height, right? Or you could say base times height over 2. So what's my base? It is 70. The height is 30. We're going to take that divided by 2. So that's going to give you 1050 meters squared. Now the area of the trapezoid, right? It's small base plus big base times the height divided by 2. So small base is 50, big base is 70, times height is 30, divided by 2. That comes out to 1,800 meters squared. Okay, so same thing as before, we're going to take my favorable area, which is the area of the shaded triangle, 1050, and we're going to divide that by the total area, which is 1,800, and that's going to give you 0.583 or 58.3%. Okay, so we have the probability of landing in this shaded region and the probability of landing in this shaded region. Which one is higher? It's a 62.8. So we should choose, or Mr. Pagano should choose field number 1. Okay. Now, question 7. Mr. Hum lists the number of hours he spent playing different video games for a week, and he makes a box and whisker plot. Later, Mr. Pagano tells Mr. Hum that he took the list but lost it while skydiving. So Mr. Hum remembers 4 out of 7 numbers, and he still has that box and whisker plot that he made before. So here's 4 out of the 7 numbers that he remembered, and here's the box and whisker plot. Okay, there's obviously some information that's missing here, the max and the Q1. So Mr. Hum is missing the amount of time he played Roblox, Fortnite, and Minecraft. But he also knows all this information as well. The game Mr. Hum played the most was Roblox. The range is 11 hours. The IQR is 8 hours. The average of the amount of time he played Fortnite and Minecraft is 6 hours, which means if you have the time he played Minecraft and the amount of time he played Fortnite, and you add them up and divide by 2, you should get 6 hours, okay? And he knows he played Minecraft for longer than he played Fortnite. And we want to know how much time did Mr. Hum spend playing each game. So we're going to have to fill out this sentence here where, we find out how much time he played Roblox, how much time he played Fortnite, and Minecraft, okay? So first things first, we know the game Mr. Hum played the most was Roblox. So when you see the word the most, or the words the most, I should say, okay, this should jump out at you and say, oh yeah, that is your max. And you see here the max isn't there. So your max is the amount of time you played Roblox. That's one of your missing values. How are we going to find what that number is? Well, we know the range is 11 hours. And remember, the range is just the distance from your max and your min, right? Is that distance between your max and min. And you can find that by taking max minus min, okay? In this case, we don't know what max is, but we know what the minimum is. And if we know the range is 11 hours, then we know the max has to be 11 numbers higher or greater than your minimum. So we know what the minimum is. It's 2. To find a number that's 11 numbers bigger than that, we just add 11, and we get 13 hours is the max, okay? And because we said the max is one of my missing numbers, we can say x1 equals 13 hours, and that's just the amount of time I played Roblox. So we can already fill that out right here, 13, right here, okay? Next, what's the next piece of information? It says the IQR is 8 hours. So IQR is very similar to range, okay? But instead of the distance between min and max, it's the distance between Q1 and Q3, okay? So if we know that Q3 is 11, but we don't know what Q1 is, right? Then to find Q1, we just have to take 11 and find the number that's 8 numbers smaller than 11, right? 8 numbers smaller than Q3. And how do we do that? Well, we just take Q3, which is equal to 11, and we just subtract 8 from that, and we should get 3. So Q1 is equal to 3, okay? And if we scroll up here, you'll see 3 is not in my list. It's one of my missing numbers. So we've used that information, yeah, okay? So Q3 is one of my missing numbers, so we can say x2 is equal to 3 hours. Is that the amount of time I played Minecraft? Is it the amount of time I played Fortnite? I'm not sure. I don't know yet, okay? So I can't really put it in one of these, blanks yet. So let's just keep going. The average of the amount of time he played Fortnite and Minecraft is 6 hours. So like I said before, if you take those two times and you add them together and divide by 2, you will get 6 hours, okay? But we don't know one of those times, but we do know that one of the other times is 3 hours, right? We know one of these, Fortnite and Minecraft, is 3 hours. The last one, we'll call that x3, okay? So if we take 3 hours and we add it to my last unknown, which is x3, and we divide by 2, I know that should give me 6 hours. So we cross multiply, we get 3 plus x3 is equal to 2 times 6. 3 plus x3 is equal to 12. So x3 is equal to 12 minus 3, which is 9 hours. Okay, so we know the last two missing numbers are 3 and 9. Which one goes with which game? We know he played Minecraft for longer than he played Fortnite. So the bigger number, which is 9, goes with Minecraft. The 3 goes with Fortnite. So we can go down here and put 9 hours for Minecraft, 3 hours for Fortnite. And that's going to be all for this test. So if you have any questions, just leave them down in the comments below, and have a great day. Bye.